Hello students, welcome you all. Now in this lecture, I will cover the topic SN-I reactions. In my previous lecture, I told you about SN1 reactions and SN2 reactions. The SN2 reactions, inversion of configuration occur. In SN1 reaction, net inversion occur, that is, the inversion product is more than the retention product. Both products are formed, but inversion products are more than the retention product. Now in SN-I reaction, so the full form of this SN-I reaction: substitution, nucleophilic, internal. Okay. Now let's see some features of this SN-I reaction. So some of the characteristic features for this SN-I reactions. First thing, what we saw in SN1, SN2 reaction, the alkyl halide undergoes substitution, nucleophilic substitution. Okay, and alcohols doesn't undergo SN1 and SN2 reaction. What we saw. Why? Because OH being the poor leaving group. But here this SN-I reactions, they are given by the alcohols in presence of SOCl2, thionyl chloride. So alcohols can undergo substitution reaction, but in presence of this thionyl chloride. So alcohols in presence of SOCl2, or sometimes we can say this COCl2 also, that is called as the phosgene gas. So alcohols in presence of thionyl chloride gives alkyl halide. Okay. So alcohol can undergo nucleophilic substitution reaction, but that reaction is called as the SN-I reaction. Now second thing, if we see the mechanism of this, then this reaction goes via the retention of configuration. So here retention of configuration occur. Okay, and next point, so the retention takes place via the formation of four-membered cyclic transition states. Okay, so in SN2 reaction, what we saw, the five-membered transition state was formed. It was not the cyclic one. SN1 reaction, the carbocation was formed as an intermediate, but here this in SN-I reaction, four-membered cyclic transition state is formed. Okay, now next point, suppose if we are taking thionyl chloride in presence of pyridine. So thionyl chloride in presence of pyridine, it gives the inversion product. So thionyl chloride gives the retention product, but if we take thionyl chloride in presence of pyridine, gives the inversion product. So SOCl2 in pyridine gives inversion product. So we will see the mechanism of this one. Similarly, suppose if alcohols are reacted with PCl5, then also the reaction takes place via the inversion of product. So alcohols in PCl5, alcohols in presence of PCl5 give inversion product. That is, the alkyl halide which is formed have the opposite configuration in comparison to the alcohols. Okay, so these are some main important points for this SN-I reaction. So let's take the example now. Now suppose if we have Now let's take the example. Suppose if I have the secondary alcohol. Now, in presence of thionyl chloride, it will give the product having the retention of configuration. The OH that would be replaced by the chloride. So if retention of configuration, it means the same side, the OH is towards us, so that's why the chlorine will also be towards us, same configuration we can write, and plus what is formed here, SO2 plus HCl, that would be formed. So this is the reaction. Now if we see the mechanism for this reaction, then we have the secondary alcohol, and this in presence of thionyl chloride. So the lone pair of electrons which are present over the oxygen atom, that will go into the empty orbital of this sulfur, and what we will get? We will get the end. Okay, now in next step, chlorine will leave out. Again a pi bond that would be formed, and this one of the chlorine will leave out. So what we may write? Okay, so chloride ion has left out. Now in next step, this chloride ion will act as base, and it will take out this proton. It will take out this proton, and the positive charge that will get neutralized. So okay, now in next step, this chlorine, this carbon oxygen bond being the weak bond, so that will break, and ion pair that would be formed. So sorry, here we will have the positive charge, and so this ion pair is formed here. So ion pair is formed, and this is the chlorosulfide ion is formed over here, and this is the ion pair which is formed. Now in next step, this charge, the pi bond will again be restored, and the chlorine, so chlorine that would be substituted over here, and what we can write? Okay, plus this SO2 gas that will leave out. So this is the mechanism where the retention of configuration is taking place. And here one of the transition state is formed. Here transition state, how we can write the transition state? So if we see the transition state which is formed over here, so one of the bond which is formed, formed, and this double bond is, and this bond is started broken out, this bond is started forming. Okay, so this is this, you can see this is 1, 2, 3, 4. 4-membered cyclic transition state is formed. So this is 4-membered cyclic transition state is formed. So this is the reaction when we have taken the thionyl chloride. In the same way, if we are taking the phosgene, then also the same retention of configuration will occur. So let's see, suppose if we are taking phosgene, the mechanism that would be same. Okay, so what we can write? In next step, a double bond, pi bond will be restored, and this chloride ion will leave out, and this would be formed. And like previous one, the chloride ion now which is left out, that will act as base, and it will take this H plus and the positive charge over the oxygen, that would be neutralized. Now this, in next step, this carbon oxygen bond that will broken out, and we will have the ion pair which is formed. And now the carbon dioxide gas will released, and here this chloride ion that will attack from the same side. So we can write, you can see the retention of configuration is taking place plus removal of this CO2 gas. So we can see the same type of mechanism, and we are getting this is retention product here. We are getting the retention product. Now suppose if we are taking thionyl chloride in presence of pyridine, that what I told you, in that case inversion of configuration occurs. So let's see, when if we are taking pyridine also, and how the inversion of configuration occurs. So suppose if we are taking pyridine, then in this case the inversion of configuration will take place. The configuration will get the opposite configuration. So if it is R, then that would be S. So if you see, then this is R configuration, because if we give the priority, then this is first ethyl group that would be given second priority, and this methyl group that would be given the third priority, and here this this is the S configuration. This is S configuration because anti-clockwise direction. So this is S configuration. Okay, now if you will see here, then because here the hydrogen is, because the hydrogen which is present over here, this is it is towards us. Okay, this lowest priority group should be away from you, but here the hydrogen is towards us. That's why the configuration that we are getting, then we should reverse that configuration. So suppose if we are getting the S configuration, then that should be written as R configuration. If we are getting R configuration, we should write the S configuration. This is the case when the hydrogen is present towards us. Otherwise, when we are writing the R and S configuration, the hydrogen should always, our least priority group should always be away from you. But here, if you will see, this is towards us. That's why the configuration that should be written, that should be reversed. So here this is S configuration, but as hydrogen is towards us, that's why we should write the R. Okay, this is R configuration. Now, so let's see the mechanism for this. Initially the mechanism is same as before. Okay, so pi bond that will break, and so again this pi bond will be restored, then it will leave out, chlorine will leave out, and what we will get? Now in next step, what I told you, the chloride ion will act as base and it will extract the proton, positive charge that would be neutralized, and so up to here, as you can see, up to here the mechanism is same as before. Now this pyridine, we have pyridine now. So this pyridine will attack the empty d orbital of this sulfur, and pi bond will break, and what we are getting? Positive charge will come over the nitrogen. Now again next step, this double pi bond that would be restored, this one of the chloride ion will leave out, and we are getting the double bond will come over here, and we have the one of the pyridine which is here having this positive charge. Okay, now what will happen now? So we have the chloride ion which is free here. This chloride ion is replaced here. So in next step, this chloride ion will act as nucleophile, and it will attack from the back side. Why? Because here now this group has become the bulky group due to the presence of this pyridine over here. This is the bulky one. That's why this chloride ion cannot attack from the same side. So that's why this will attack from the back side, and we will get the inversion product. Once it will attack back side, then what will happen? So it will go over here, and this now it will leave out. So this plus, as you can see, SO2 that is formed here, and plus this pyridine, it will give out. So this is the mechanism when the alcohol reacts in presence of reacts with thionyl chloride in presence of pyridine. Now if we take the PCl5, in presence of PCl5 also the inversion of product takes place. So if we see the reaction of alcohol in PCl5, then also inversion of product. So suppose if we are taking alcohols in presence of PCl5, that can also give the substitution product, and here also the inversion of configuration takes place. So this would be formed. Okay, so this is about the SNI reaction. Now in my next lecture I will discuss about the SN1 dash or SN1 prime and SN2 prime reactions. Thank you.